friends, welcome back to my channel. I am Sushma. Today we are going to learn polynomials and real numbers lesson 2 and 3 mark questions. Here we have a first question. If the 0 of the polynomial x square plus kx plus 4 is minus 2, then the value of k find. They already said 0 of the polynomial, how much they said? Minus 2. So therefore x is equals to one value there, that is minus 2. Another value we don't know. But we need to find out using 2, we need to find out k value. Now I'll take the equation, what I have equation x square plus kx plus 4 is equals to nothing is there, so therefore I mention 0. And we already know what is the x value, minus 2. So therefore minus 2 whole square plus k into x value we have minus 2 plus 4 is equals to 0. Minus into minus plus 2 2s are 4. So 4 plus minus into plus minus only. So minus 2k. I'll mention like that only. Plus 4 is equals to 0. Now we can see we have a 2 constant term, that is 4 and 4. I'll add both. I'll get minus 2k plus 8 is equals to 0. Now I'll take 8 that side. So I'll get minus 2k is equals to minus 8. Minus minus cancels. You'll get k is equals to 8 by 2. 2 1s are 2 4s are, you'll get k is equals to 4. Second question, if the sum of zeros is root 2 and the product of zeros is 1 by 3, find the polynomials. They said sum, that means alpha plus beta is given, that is root 2. They said product, that means alpha beta is 1 by 3. We already have one of the required polynomial equation. So the required polynomial is equals to, we have an equation, that is x square minus alpha plus beta x plus alpha beta. So this is one of the required equation we already have. You need to remember this. Now we will substitute the values. So that is x square minus alpha plus beta we have root 2x plus this is we have 1 by 3. So we have 1 by 3. So therefore now I'll take a LCM. So by taking LCM, that means I'll multiply here by 3 and here also I'll multiply by 3. So then I'll get 3x square minus 3 root 2x plus 1 divided by 3. Here nothing is there, equal to 0. So therefore now I'll do the cross multiplication with the 3. I'll get 3x square minus 3 root 2x plus 1 is equals to 0. This is one of the required polynomial equation. And you need to properly observe, if they mention sum and product only you need to take. If they said only the zeros of the polynomial, means it's not a alpha plus beta, it's just alpha and beta separately. So that's you need to observe and you need to do. Find the polynomial whose zeros are root 3 and minus root 3. They not mention any sum or product. So therefore we need to write alpha value is root 3 and beta value is minus root 3. First we need to find out alpha plus beta because we need a polynomial equation. So therefore only alpha plus beta means root 3 plus of minus root 3. Plus into minus we will get minus. So therefore root 3 minus root 3 it will cancel, we will get 0. Next alpha beta we need to find out, that is root 3 into minus root 3. Root 3 into root 3 is root 3 whole square, minus will be like that only. So root 3 whole square minus and square and root cancels, you will get minus 3. Now the required polynomial, we already know the equation, that is x square minus alpha plus beta x plus alpha beta. So we know the values, I substitute now. 0 into x plus this is minus 3. Already this is 0 with anything, that's 0 only. So therefore you will get x square plus into minus 3. This is one of the required polynomial. Fourth one, find the HCF of 135 and 225 using the Euclid's division. So they said two numbers, we need to see which is the biggest one, which is the smallest one. We have a biggest one is 225, that will come inside of the division, and this will be 135 outside. So by which table it will divide? So that 135 ones are only it will go. So therefore 135 ones are 135. So by subtracting I'll get 90. So therefore step 1 we will get as what we have 225. That means divisor is equals to dividend, that is 135, and quotient we have 1 plus 90. You can see 135 into 1 is 135 plus 90 you will get 225. Same, now what we got? Now we need to take 90 outside. From that we need to divide 135. Whatever you will get the remainder, by that you need to divide. 90 again it will divide by 1s only, because 2s it will become more. So by subtracting I'll get 45. So now step 2 we will write 135 is equals to 90 into 1 plus 45. Same now, 45 will be outside, 90 will be inside. So now we need to divide. So 2s it will divide. How much we'll get? 45 2s are 90. So we'll get 0. Therefore we can mention 90 is equals to 45 into 2 plus 0. So now we can see what is the HCF we got, by which one it's finally dividing and we are getting 0, that is 45. So therefore HCF is equals to, we'll get 45. That's the answer. Fifth question, prove that 5 root minus 3 is an irrational number. So in this, first of all we need to do the assumption. So let us assume 5 minus root 3 is an irrational number is there. So therefore you need to mention rational number. So if it's rational number means what we will get? So 5 minus root 3 is equals to p by q, because it needs to be in the form of p by q, where p comma q belongs to z and q is not equal to 0. Now I'll take this one 5 this side. So then I'll get 5 is equals to, root 3 is equals to p by q, that plus this one it will become minus 5, this will be minus root only. So minus root 3 is equals to, you can observe here nothing is there is 1, so we need to take LCM, multiply by q. I will get 5 minus p minus 5q divided by q. You can observe here I have a minus, here we have nothing, so therefore I'll multiply both the sides, multiply by minus on both the sides I'll do. So then I'll get root 3 is equals to, plus terms will become minus, minus terms will become plus. So I'll get minus 5q will become plus 5q and p will become minus p divided by q. So therefore finally we can write root 3 is rational number and 5q minus p divided by q is also a rational number. With contradiction we can say that we can finally say that root 3 is an irrational number. If you can't write like this, you can write 5q minus p divided by q is an rational number, but root 3 is an irrational number. Therefore our assumption is wrong. Instead of contradiction you can write our assumption is wrong and root 3 is an irrational number. You can write like this as a statement. Sixth question, show that 35 by 50 as terminating decimal expansion without long division. For terminating expansion, you need to have that in the form of 2 power n into 5 power m. So therefore we need to have means denominator need to be in this form. So therefore I need to check is it 50, we will get or not. So first I need to take LCM. So is it divided by 2? Yes. So you will get 2 2s are 4 and 2 5s are 10. So now again by 5 to divide, so 5 5s are, so 5 1s are. So what is our 50 we're getting? 2 into 5 into 5. So 5 power nothing will be, so that means 1 into how many 5s we have, that is 2. So 2 power 1 into 5 power m. So therefore you can write 35 by 50 is equals to 35 by 50 we can write as a 2 power 1 into 5 power 2. Therefore we can see that the denominator, it's in the form of 2 power n into 5 power m, that is n is equals to we got 1 and m is equals to we have 2. Therefore we can say this is terminating decimal. In this you no need to do the division of upper one, because many they will do the divide, otherwise many they will take LCM of both. Only denominator LCM you need to take and you need to solve. If you like this video, please share with your friends. For more like these videos, best press the bell icon. If you have any doubt, please comment it below and like this. Thank you.